Welcome to Chapter 4. Today we are starting our section on trigonometry. For the beginning, we're going to focus on right triangle trigonometry, which means actually involving triangles. As we move through, we're going to look at trig ratios as functions. We're going to move away from actual triangles a little bit so that we gain versatility. But for right now, we're going to focus on right triangles. So they look like this. In geometry, you're supposed to have learned sine, cosine, and tangent, and what they represent is actually families of triangles. So regardless of how big or small a triangle gets, triangles with the same angles have the same ratios to their sides. They're similar triangles. So we have actually families of triangles. Any right triangle with one of its acute angles being 20 degrees is going to be similar or have the same proportions to any triangle that's a right triangle with an angle of 20 degrees. So, for example, if you take the opposite side opposite your 20 degree angle and divide it by the length of the hypotenuse, you'll get the same fraction every time as long as this angle is 20 degrees. So in order to account for this, we've created some functions, sine, cosine, and tangent, where basically the sine of a given angle, like say the sine of 20 degrees, is going to be the length of the opposite side divided by the length of the hypotenuse. And no matter how big or small your triangle is, if that angle is 20 degrees, then this ratio will be the same. For example, sine of 30 degrees is always 1/2. And that'll be true no matter how big or small the triangle gets. The hypotenuse will be twice as big as the opposite side. The cosine focuses on the adjacent side divided by the hypotenuse, and the tangent is the opposite side divided by the adjacent side. So we'll do some examples here in a minute where we actually divide those and get the fractions. But these are the three you were supposed to learn in geometry, and it turns out there's three more because each one of these has a reciprocal. So the reciprocal of sine is cosecant. The reciprocal of sine is cosecant. Now the ratio for cosecant is hypotenuse over opposite, which is just the reciprocal of the sine. And the secant is the reciprocal of cosine, and the cotangent is the reciprocal of tangent. So it's just you're dividing the opposite sides. I will be talking about them some, although I don't think you're going to see the names again, so note those. CSC is cosecant, SEC is secant, and then COT is cotangent. So that's the 6 trig ratios. And when we talk about them, we're going to do a lot where you got to figure out all 6 for a given triangle. So the triangles I'm going to start with, we call this, I think your book says special triangles. We call them common. The most common angles that we like to deal with are 45 degrees, 30 degrees, and 60 degrees. And so we fit them into 2 special right triangles that you're supposed to have memorized in geometry. But in case you've forgotten, we're going to go over them. I'm not going to require that you memorize these because by the time you get to your Chapter 4 test, we'll be using the unit circle, which has the same information. So that's where we'll focus our memory work. So the 45, 45, 90 triangle, we usually put the legs to be 1. And by the Pythagorean theorem, 1 squared plus 1 squared would have to equal the hypotenuse squared. So that's going to be square root of 2. So for 45 degrees, then we can figure out the sine, the cosine, well, all 6 trig ratios. So when we do sine of 45 degrees, we'll pick either one of the 45 degree angles. But sine is opposite over hypotenuse, so we're going to see 1 over the square root of 2. The cosine of 45 degrees will be the adjacent side over the hypotenuse. So again, 1 over the square root of 2, because this triangle is symmetric. The tangent of 45 degrees will be the opposite side divided by the adjacent side. So that's 1 over 1, or 1. If we did the cosecant of 45 degrees, we're going to get the same values, just reversed. The cosecant is the hypotenuse over the opposite side. So square root of 2 over 1, which is just square root of 2. The secant will be the hypotenuse over the adjacent side. square root of 2 over 1 is square root of 2. And then cotangent adjacent over opposite, which will be 1 over 1 again, or 1. If we move on to 30 degrees, the 30-degree triangle, the most important thing to remember is the side opposite 30 degrees is the smallest, that's 1. And the side opposite 90, the hypotenuse, is the biggest. It's twice as big. So the sine of 30 is 1/2. Once you have those, you can remember the third side by using the Pythagorean theorem, right? This side squared plus this side squared equals the hypotenuse squared. So 4 minus 1 gives you 3. So the square root of 3 is this missing side. It's about 1.7, so it's in between 1 and 2. Either way, the cosine of 30 degrees will be the square root of 3 over 2. My heat kicked on. I don't know how loud that is. Pretty loud. Alright, so the square root of 3 over 2. The tangent will be 1 over the square root of 3. You should remember to rationalize those when you're doing them in your homework. Well, on tests anyway. In your homework, I don't care as much. The cosecant for 30 will be the reciprocal of that, which is 2. The secant for 30 is the reciprocal of this one, which is 2 over the square root of 3, or 2 square roots of 3 over 3. And then the cotangent will be the square root of 3 over 1, which is just square root of 3. When you switch angles to 60 degrees, the sine and cosine will switch. So the sine of 60 degrees is going to be square root of 3 over 2. The cosine of 60 degrees will be 1/2. And the tangent of 60 degrees will be square root of 3. And of course, the reciprocals, the cosecant will be 2 over the square root of 3. The secant of 60 will be 2. And the cotangent of 60 will be 1 over the square root of 3. You can use one trig ratio to find all the other 5. And that's one of the skills that we're going to practice. In this case, we've got the secant is 5/3. So what this actually does is it tells us 2 of the sides on a triangle. We could use any multiple of 5 if we use the same multiple of 3. So like you could use 10 and 6, but really bigger numbers worse. So we're going to assume the smallest triangle we can. So we're going to draw the triangle where secant equals 5/3. So we draw a right triangle. We've got our angle here. Now secant is the ratio of hypotenuse to adjacent. So the hypotenuse we're going to say is 5, and the adjacent side is 3. To do all 6 trig ratios, we need the third side. Pythagorean theorem will do it for us. It says 3 squared plus the missing side squared equals 5 squared. So that's 9 and 25. So we subtract the 9 to the other side and take the square root, and we get 4. You can think of it as plus and minus 4, but since it's an actual triangle, we're going to assume positive 4. Once we have the third side, finding all 6 trig ratios is easy. Sine is opposite over hypotenuse, 4/5. Cosine is adjacent over hypotenuse, 3/5. Tangent will be 4/3. The cosecant will be 5/4. The secant will be 5/3. And the cotangent will be 3/4. That's actually it for 4.1a, which is the part that's due tomorrow. It's just using the ratios. Solving a triangle, we're going to be using our workday tomorrow. It'll be due on Monday, 4.1b, which you'll also see in Google Classroom. When you're solving a triangle, what that means is there's sides you don't know or angles you don't know, but we're going to start with sides. And you're going to use trigonometry in order to find the missing side. So if there's a side you're trying to find and you know one of the other sides and an angle, you can use the appropriate trig ratio. So you look at the angle you have, you decide which ratio covers the 2 sides you're talking about. In this case, that's the adjacent side and the hypotenuse. So you're going to want cosine. So the cosine of 52 degrees should be equal to the adjacent side, A, divided by the hypotenuse, 9. And that you'll need to put into a calculator. Make sure if you're using Desmos, you click on the wrench. Make sure it's in degree mode and not radian mode, or you'll get the wrong number. But to solve this for a, you just multiply by 9. So 9 times the cosine of 52 is 5.541. You can round that to the nearest tenth for side lengths and nearest degree for angles. So you can report that as 5.5. That's the second side. If you're supposed to solve the whole triangle, you'll need to keep going, although sometimes the instructions just have you find one side. If you want to find the third angle now, or third side now, there's a few different options you have. You have 2 of the sides. So you can use the sine now, which is opposite over hypotenuse, in order to find the third side. You can use the tangent, since you have the adjacent now as well. Opposite over adjacent would be the tangent of 52. Or you can use the Pythagorean theorem, which is my preference, but you can do it whichever of those 3 ways you want. If you need to find the last angle, remember that all of the angles in a triangle add up to 180 degrees. The process is a little different for if you're missing an angle. So if you have 2 sides and you need to find the angle, the trick is to actually use the inverse sine, inverse trig function. So the sine function is designed for you to put in an angle, and it gives you a ratio of sides, a fraction or decimal. The inverse sine, which you can also type in as arc sine, that will be the one where you stick in a ratio of a decimal or a fraction, and it gives you an angle. Again, make sure you're in degree mode if what you want is an angle in degrees. In this case, the angle is 27.82, and once you have one of the sides, or one of the angles, the third side, Pythagorean theorem is probably easiest, and to find the other angle, remember the 3 angles have to add up to 180 degrees. So you use inverse trig functions to find angles, you use regular trig functions to find missing sides in the ratio. Just some advice about electronic tools. Make sure you're in the right mode. Degrees or radians. Most of them default to radians. So for now, you got to switch it into degrees. We'll learn radians in 4.2. Keep track of whether you're using sine or inverse sine. In sine, you're sticking in an angle and getting a ratio. Inverse sine, sticking in a ratio, getting an angle. Be careful of your shorthand. Desmos is okay with sine squared, but a graphing calculator is not. So make sure you put your argument in parentheses so that you square it on the outside of the parentheses. That squares the answer to sine rather than squaring the x. And school yourself, discipline yourself to close your parentheses. On the TI-84, it's kind of forgiving, but a lot of other electronic tools aren't. That should be what you need to get started. Good luck on your homework, and I hope to see you tomorrow.